and welcome to Chapter 2, Section 3. Today we are talking about measures of central tendency. So what this means is, in a data set, what number can we kind of talk about our data set with as like a center? So a lot of these you've heard before: the mean, the median, the mode. So mean, hopefully you remember, is an average. So you would take all the numbers, add them up, and then divide by how many you have. So the average kind of tells us like a center because it basically is like what all of the numbers are around. The median is also considered a center because the median is talking about what is the middle number. If you put all your numbers in order, what is that middle number? And then finally, the mode is another way to talk about the central tendency because as a center, it's kind of like what number occurs the most. So mode is a little awkward. If you have no repeats in your data set, then you're not going to have a mode at all. If you have more than one number that repeats itself, then you want to look at which one repeated the most. Then that would be your mode. If there's like two different numbers that repeat the same amount of times and they're both like the most amount of times, then you're going to have two modes. And it is possible to have two modes. So I want to do an example together, actually using the calculator to calculate our mean and median because, if we have a calculator, if we have the technology, why not use it? So in this data set, we're going to try to find the mean, median, and the mode of the sample ages of a college class shown. Which measure of central tendency best describes a typical entry of this data? Are there any outliers? So first, let's talk about the outliers. If you remember, outliers are any data points that are far away from the rest of the data. So it could be like really small, really big. As long as it like doesn't fit along with the rest of the data, that counts as an outlier. So first, taking a look at our data set, we can kind of see that 65 is kind of a bigger number than the rest of everything else. So we have an outlier there at 65. Okay, so now I'm going to use my calculator to calculate the mean, the median, and the mode. If you don't have a graphing calculator, then you can just do it the normal way. Add everything together, divide by how many there are, or put all the numbers in order, find the middle number. So using my calculator, first I'm going to turn it on. And then we want to put all our numbers into the list. So remember, to get to the list, you're pressing the stat button, that's our favorite, and then edit. So I'm going to put all my numbers into L1, so I'm going to start typing in all of my numbers in, 20, 21, 23. Okay, so just put all my numbers into the calculator. So to find the mean and the median really quick, the easiest way is this. So from your list, you want to get back out into the home screen so you can do some calculations. So to do that, second and then the mode button will take you back home. Then we're going to go back into second stat. So second stat is where we want to do all our math stuff. So before we've used like ops before to put our numbers in order, but this time we're doing some calculations. So we're going over to math. So under math, you'll see these are all the things that your calculator can find for you. So you can find the smallest number, biggest number using min and max, but we want the mean. That's number 3. So hit enter and it'll say mean parentheses. So you just want to tell the calculator which list of numbers that you want to find the mean of. So we put all our numbers into L1. So L1, we want to type in the blue L1 right there above the number 1. So second and then number 1, end our parentheses, and then hit enter. It'll calculate the mean for us. So we got a mean of 23.75. We're going to do the same process to find the median. So second stat, go over to math, and then median is number 4. Then I'm going to type in L1 again, and the parentheses, hit enter. So my median is 21.5. Unfortunately, the calculator does not find the mode for you. So even if you checked that same spot where we do all our calculations, mode is not one of the choices here. So that's unfortunate, but mode is easy to find. So just look through your data set, what repeated the most. It looks like we saw 20s a lot. There were 1, 2, 3, 4, 5, 6 20s. Another number that repeated a lot was 22, I think, but there were only 1, 2, 3 of those. I think 21, 23, and also repeated a bunch of times, but not as many as 20. So our mode is going to be 20, because that repeated the most. Now that I've found the mean, median, and mode, I want to answer the question, which measure of central tendency best describes a typical entry in this data set? So we were basically trying to say, like, which of these three things best measures like what is considered the center. So if we look at our mean, we got 23.75, which, looking at the rest of our numbers in our data set, which kind of makes sense because it looks like we have a bunch of 20s, and then a few of the 21s, 22s, 23s kind of repeat the same amount. 24, there's like 2 of them, and then we've got this one 65 all of a sudden. So the mean is kind of saying that the middle number is kind of like 23.75, which I feel like there's more numbers that are closer to 20 and 21, 22 than there are of the 23s, 24s, which is what we're saying is the mean. So maybe I'll keep that in mind. But the median is 21.5, and as a measure of central tendency, it does seem like we have more numbers that are like 20s, 21s, 22s, so that kind of makes more sense. And then the mode is saying is the 20, but 20 is also our smallest number, so I don't know if I would consider that my like center at all. So because of those reasons, I probably think that the median is the best measure of central tendency, because the median is the closest to what we would consider our center here, where most of my numbers are between 20, 21, 22, where there's fewer numbers between 23 and 24. So the mean doesn't really make as much sense. The mode definitely doesn't make sense. But also, because we started out with an outlier of 65, anytime you have outliers, medians are usually better as the measure of central tendency, because if you have an outlier, that means that like when we find the mean, when we add up all the numbers together, that actually affects our mean a lot, because then we end up adding a huge number, or if it was like a really small outlier, then we end up adding a really small number to find our average, and that gets affected. Versus the median, when we just look for that middle number, then whether you have an outlier or not at the end of your data set, because when you put things in order, your outliers would either be at the really small end or really the big end, then the median doesn't get affected at all. So if you have outliers, use median as your best measure of central tendency. If you don't have outliers, then mean is usually pretty good, because then calculating the average would be pretty accurate as a measure of center. Okay, now that we know how to find the mean, median, and mode, and the best one to use when depending on our data set, let's talk about other types of means, or other types of central tendencies. So this is more for if you don't have just like a set of numbers. So a weighted mean is when you have a set of numbers, but each number in the data set is worth a different amount. And this is the most used when we are calculating grades in classes. So if each of your assignments are categorized using the homework category, the classwork category, or the tests and quizzes category, like our class is set up, then each of your grades in your grade book are worth different amounts. So to calculate a weighted mean, this is the formula for it. It looks a little crazy because there's so many symbols, but really what this means is if you have your grades, W stands for the weight of your grades, then you're going to multiply your grades with the weights. And then this symbol out here that looks like an E, that just means sum. So you're going to add up all those things multiplied together and then divide by all the weights added together. It's probably best to do an example with this, that way we can kind of see how the numbers are used. So pretend we're in a class where your grade is determined from 5 sources. So 50% is your test. So 50% of your grade is from your test mean, 15% is from your midterm, 20% is from your final exam, 10% is from your computer lab work, and 5% is worth your homework. So your scores for each of those categories were 86 for your test mean, 96 for your midterm, 82 for the final exam, 98 for the computer lab, and 100 for the homework. What is the weighted mean of your scores? So let's calculate that. So first I'm going to start listing out all the grades that I have. So those are my X's, because X stands for grades. So 86 was my test mean, 96 was midterm, 82 for my final exam, 98 for computer lab, and 100 for homework. So then I'm going to match up my weights with each of those scores. So if 50% was my test mean, then I'm going to turn that into a decimal because we don't really deal with percentages or like do any calculations with percentages themselves. We always use the decimal. So 0.50, if we move the decimal place 2 places to the left from a percent to turn it into a decimal. 0.15 for the midterm since it was 15%. 20% for the final exam. 10% for computer labs, and 0.05 for the 5% for homework. Okay, once I have all that listed out, I'm going to multiply my x's times my w's and write them over here. So 86 times 0.5 is 43, and then I'm going to continue doing this with the rest of my numbers. Okay, after getting these numbers, then the next part of my formula, I want to add up, so the sum of all my x times w's. So I'm going to add up all the numbers in this column for the x times w column. I ended up getting 88.6, and then I'm going to add up, so the sum of w, which means add up all the sums of all my numbers in the w column, so my weights, I end up getting 1 for that. So dividing these two things, 88.6 divided by 1 gives me 88.6. So that's my final grade. So, which is like a B+. If the minimum average for an A is 90, did you get an A? That's a no. Wah wah. Another measure of central tendency that we want to be able to find is the mean of a frequency distribution. So in section 1, we talked about frequency distributions. This is where we made the table with like our class limits and the midpoints and the frequencies, all that good stuff. So basically, if you're given one of those, we also want to be able to find the mean of it. So the formula is similar to the one that we had for the weighted mean, except instead of x times w, we have x times f, where f is the frequency and x is the midpoint. So in this problem, I've already given you the midpoints, but in case you needed a refresher, a midpoint is when you take the first and second numbers of your class limits, add them together, divide by 2. That's how you get your midpoints. So we're basically going to do the same thing that we did last time. So we're going to find our x times f. So multiply your midpoint with your frequency, and then we'll get all those numbers there. So 12.5 times 6 would give me 75. 24.5 times 10 is 245, and I'll continue on. Once I've gotten all those numbers multiplied out, then kind of like before, we're going to add up our column of the x times f, and then we're going to add up our, instead of our weights, we're going to add up our frequencies so that we can get the sum of x times f and the sum of f. So adding up all my x times f's together, I got 2089. Adding up all my frequencies together, I got 50. So now we're taking our x times f's divided by our frequencies. So I get 41.78. And since this problem was talking about the number of minutes that a sample of internet subscribers spent online during their most recent session, basically our average amount of minutes would be 41.78 minutes. The last thing I want to talk about in our section is the shape of distributions. So we've been making graphs. Now we've talked about the center of the graphs of our data sets. So now we want to talk about like how we can describe the shape of our graphs. So the distribution of the data points themselves, what does it look like? So we have 4 options: symmetric, uniform, skewed left, skewed right. Those are our options. So we basically want to just look at the overall shape of our graph, and that's how we describe what kind of shape it's going to be. So the first shape, symmetric, just means that if you split it down the middle, the two sides are pretty much mirror images of each other. And it doesn't have to be exact, as long as it's close enough. So when I say like pretty much, that's what I mean. So it doesn't have to be exact, but if the two sides are pretty much the same, if you were to mirror them, then that would count as symmetric. The second one is uniform. Uniform kind of means like the same. So if all the bars in our graph are about the same height all the way across, then it would count as uniform. And again, it doesn't have to be like exactly the same all the way across if they're pretty close, like this. The next two are skewed left and skewed right. They're basically opposites of each other. So skewed left means that the shorter bars are on the left. It means that you have less data points on that are smaller numbers and lots of bigger numbers in your data set. So then that's why the taller bars are on the right. Skewed right is just the exact opposite. So you have a whole bunch of smaller numbers because it's towards the left of the graph, but then shorter bars on the right, meaning you have fewer in your data set of the larger numbers. So knowing our shapes, it's actually pretty easy to tell where the mean, median, and mode would be within each of our graphs. So looking at symmetric, if it's the same on both sides, then that means the mean and the median should be right in the middle. So the median, when it's symmetric, is going to be pretty much the mean, and then the mode is supposed to be when it occurs the most. So if we look at a histogram, it would be the tallest bar. So when it's symmetric, the mean and the median and the mode are all the same number. If it's uniform, that means it's still symmetric because we can technically mirror image the two sides. So that means the mean and the median are the same, except there wouldn't be a mode because there's nothing that would repeat the most, since they all repeat the same amount. Skewed left, so the tallest bar would just be your mode. And then, because you have a few smaller numbers, because there's less things on the left, that would actually pull the mean down that way. So the mean would be smaller. Versus the median, since the median is like the middle number, if we have more numbers to the right of the graph, more data points, then the median would also be closer to the right. And so the skewed right would just be the opposite then. So skewed right is when the median is smaller than the mean. And that's it for this section. Thanks for watching. Bye.